Hi, my name is Grant, and thank you for watching the Orientomotor technical video. Today we'll be discussing the flex drive and the benefits of networking. There are many popular industrial networks currently on the market. As you can see via the screen here, each manufacturer has prone to their own specific network protocol. So depending on the system you're currently using, it may prove difficult to find specific components that meet those network requirements. Industrial network consists of approximately 4 layers. The upper level layer, or computer level, is usually TCP/IP or Ethernet-based protocol. In the past, it has been other protocols such as controller link. This higher level controller will consist of management of the entire factory or facility level. Then there is the controller level listed in yellow. This is usually communication between PLCs or master controllers. In the past, there's been some proprietary protocols available depending on which manufacturer you're using. But now most of that is migrating towards Ethernet again. The device level is listed in blue. This will be things like servo motors or motion control systems, and there are many different protocols available currently on the market. One of those examples would be CC-Link or DeviceNet. This is the target area which Orientomotor is specifically referencing. And then finally there is sensor or actuator level, and again there's other protocols available for this as well. In the past, with motion control systems, they have been set up primarily using I/O for control or pulse and direction for positioning systems. For example, for an AC motor system, usually I/O control is sophisticated enough to control the motor by turning on and off relays. For brushless or AC speed control systems, we can use transistors from the PLC to activate I/O function like forward and backwards or run and stop. For a stepper or a servo system, we can send a pulse and direction stream from the PLC. If the PLC is not capable of sending a step and direction signal, we can substitute using a motion controller between the PLC and the motor driver, and then simply use I/O functions to activate each sequence. Now, with the implementing of network control products with serial communications, we can simply make one connection between the brushless or AC speed control driver or stepping motor or servo driver between that of the master controller. One of the overall benefits to networking is reducing cost. One master controller can connect to over 30 axes. And also, in a smaller system, it's very simple to add extra axes by using multi-drop. This diagram showcases a master controller connected to a multi-drop system. Another benefit will be a reduction in wiring. In the past, with an Alpha Step Plus driver connected to a PLC, depending on what functions were necessary, on average, by the time you send a couple of pulse and direction signals, a couple of alarms or outputs or current off inputs, and then pulse feedback, we could have a total of about 20 wires. Likewise, when a PLC is connected to one of our motion controllers, there could be up to 14 points of I/O between the PLC and the motion controller, such as the EMP, and then between the EMP and the stepping motor driver, there could be up to 7 points of I/O, for a total of 21 I/O connections. Now, with the introduction of networking products, we can greatly reduce that. In general, serial communication can be between 3 to 5 wires, depending on whether you're doing RS-485 or RS-422. This equates to less wiring time, which means less labor, as well as less wire trouble, which means reducing the overall setup time and or troubleshooting times. Because the serial communication uses differential signals, it's superior to that of I/O control because it has a noise canceling effect. So now it's very possible that you will be error-free and also less likely to be susceptible to different types of noises in a factory environment. One of the thought we put behind our protocol was choosing an open protocol which is compatible with many different manufacturers' devices. This equates to better availability. When considering an open protocol, more than likely it's a common protocol which can be used in not only the US, but also in Europe, Asia, and other places abroad. And now I'd like to introduce the flex drive concept. In the past, like we have shown, a standard stepping motor driver would simply accept a step and direction signal. Now with our flex drive, the unit has a built-in motion controller. You can access that motion controller via 3 methods. The first method you could use is I/O control. By utilizing software or a digital operator, we can control and set parameters and data internally in the motion controller. We can then execute those parameters and data via I/O signals. The next method we could use is RS-485 communication via Modbus RTU protocol. We can connect to a PLC or HMI device and send direct serial commands to our flex drive product. And finally, we can implement other proprietary protocols such as CC-Link or Mechatrol-Link utilizing a network converter to convert over to an RS-485 signal to directly communicate with our flex drive. When using a network converter, such as a CC-Link converter, we can use multiple flex drives on the same multi-drop system. This gives the user an advantage of flexibility. In a factory where sometimes you may be using one protocol but then have to switch over to another, instead of switching out the entire product line of steppers and stepping motor or brushless DC motors, we can simply just change out the network converter to switch to a different protocol. This gives the option to switch to multiple protocols in a very short amount of time with greater flexibility. And since there's so many different protocols out on the market, this gives the user somewhat of an advantage. The current available protocol converters are CC-Link, Mechatrol-Link 2, and Mechatrol-Link 3. However, we are under consideration and currently have more under development. If there is a specific protocol that you have concern with, feel free to contact us at any time about it. So the next method of control is the I/O control. The user does have access to up to 63 different motion profiles. They also have access to end torque limit outputs, area outputs, and ready outputs, as well as many others. And it also allows for simple operation. Here's an example of our 8 general inputs for I/O control. We can see that they're 24-volt DC connections, and this can be configured for either NPN or PNP. We also have capability to hook up direct sensors, such as a home sensor, limit sensors, or a slit sensor. These are based off 24-volt, again, can be configured for NPN or PNP sensors. We also have 6 outputs available. These outputs will run anywhere from 12 to 24 volt, 10 milliamps or less. Depending on your system requirements, you may have to add an external resistor. Again, capable of both NPN or PNP. So for example, if we're utilizing I/O control, we want to access the first position, or position number 1, we would simply manipulate the M0 through M5 to toggle between the 0 to 63 different profiles, and then simply activate the start input. Once we activate the start input, motion will immediately begin to operate, and we can see that it also manipulates different outputs. Move and ready outputs are available. The user does have the ability to completely customize the inputs and output as they see fit for different functions. In this example, say utilizing a brushless DC system, we can click on the forward or reverse input and again utilize the M0 through M5 inputs to switch between different speeds. Here's an example of a motor operation when changing speeds. And finally, the unit is available to have general Modbus RTU control over RS-485. You can access all of the same functions and features that you can have access to utilizing the software or the digital operator, but using Modbus commands. You can also monitor the physical I/O. So not only can you do direct motion commands, but you can also monitor general inputs and outputs from the device as well. You have the ability to monitor the position, the speed, alarms, and much more. You also have the ability to change operation data on the fly. So this would be ideal for direct HMI or PLC control, but it's also versatile enough to integrate with other PC control systems. Anything that's capable of communicating Modbus RTU over 485. If you do have any questions, feel free to contact us at 1-800-468-3982 or email us at techsupport@orientamotor.com. For more information on our FlexDrive product, feel free to browse other product technical videos. My name is Grant, and thank you for watching.